Hello everybody. Welcome to our session today on Survey Analyst. We appreciate the time that you're spending with us this morning to learn some of the basics about Survey Analyst, this revolutionary technology. My name is Mike Weir. I'm the Survey and Industry Manager at ESRI, and I'm also the Product Manager for this new product, Survey Analyst. With me today is Christine Leslie. Christine Leslie is a product specialist on the Survey Analyst team. Christine Leslie is an expert on Survey Analyst and will assist me as we go through our presentation today to answer some of your questions. The seminar today that we're conducting, this is an overview of the seminar. The topics that I'm going to discuss that we're going to present to you is Survey Analyst and measurement data. We're going to talk about what Survey Analyst is and really focus on measurement data so we have a good understanding of what Survey Analyst really does for us. We're going to look at how we add, link, and update GIS features using survey points, the data that we've loaded from survey measurements. The format of this presentation today is that we have a slideshow. So I'll be presenting slides with a discussion. After each topic, there'll be an opportunity to conduct a short review and answer some of your questions. So what is Survey Analyst? Well, Survey Analyst is an extension to ArcGIS. Extensions to our core GIS system, ArcGIS. And extensions are designed to extend the functionality in specific areas or for specific industries, such as agriculture, land use, fire and safety, or survey, and specific applications such as parcel editing, routing, and survey integration. Survey Analyst is our surveying environment. It's the environment in ArcGIS where you can manage survey data and perform an integration in this system of survey data and measurements and a GIS system. This is a geodatabase solution for survey data. What that means is for the first time, the survey data, the measurements are loaded into the geodatabase where we can use those to impact and affect our GIS system. Survey Analyst is a set of robust tools and procedures for managing survey data. Not only do we load the data into the GIS, but you can actually manage the data. In other words, you can perform survey-type operations on survey measurements. Survey Analyst also provides a set of robust tools and procedures for representing measurements and points or survey data on the map. For the very first time, you'll see a very tight integration of survey measurements within a GIS system. So what I'd like to do is give sort of a general overview, general concept of how this is going to work. And hopefully you'll see the impact of this new technology. First of all, the general concept is that when we're working with GIS data, we're generally working with layers of data or themes, often called thematic data layers. So we might have a layer in our GIS system that represents, for instance, buildings. We might have a layer that represents land ownership or transportation, or you see some of the other layers listed there on the screen. GIS systems organize the data as layers, and we operate on layers individually. So what I want to do now is, for instance, take a look at the buildings layer. In this configuration, we have a theme called buildings. I have a layer called buildings. And when I operate on that in terms of editing or adding features or adjusting features, I'm going to work on a feature level. So I've identified a building, for instance, that I've selected from that layer that I want to perform operations on. Now, that building or that feature has coordinates, and those coordinates define the location or the corners of that feature. They define the location of that feature. So here you see the red dots at the corners of the building, for instance. Now, what we want to do is we want to introduce a new concept, and this new concept is a measurement database. This measurement database is an implementation in ArcGIS for survey data. So here you see, for instance, what's contained in that measurement database. First of all, we have survey points. So the points or monuments that are survey measurements are taken from are part of the survey data or part of the measurement database. At those survey points, we conduct measurements. So observations or measurements are conducted at those points to define features on, above, or below the surface of the earth. Those measurements are then computed to resolve locations. So the measurements, the computations on the measurements resolve coordinate locations for those survey points. And then those survey points are adjusted in coordinate space using survey methodology. Now what we have is we have the survey points and GIS coordinates associated with those points. The purpose of this is to select those same features in my GIS layer, such as those building corners, and then perform an operation of linking where we select an individual feature, link it to the survey point, and then we can perform operations such as adjusting, snapping that feature to its new surveyed location. So this is what Survey Analyst, this is the general concept. We have a feature layer, we have features that have coordinate locations, we introduce measurements into a database, perform survey computations to identify points, and then we link GIS features. This allows us to very accurately improve the quality of our GIS data. So what I want to do now, we talk a lot about measurements. I'm going to offer this audience poll. And what I would like you to do is take a few moments, take a look at the question. Which of the following are not measurement data? And there are 4 choices: temperature measurements, bearings and distances, field observations to locate or map geographic features, or coordinate pairs. So which of these are not or would not be considered measurement data? What I'd like you to do is go to the lower right-hand corner of your screen where you see the audience poll and select one of those choices. And we'll come back to that in just a moment. So what is measurement data? Well, we want to define measurement data as data that is collected to identify points on, above, or below the surface of the Earth, and measurements that would affect the computations or the value of those measurements. So on the example you see here on the screen, you see a closed traverse of maybe a lot survey. And what happens in this process is an instrument is set up at, for instance, point A. The angles are measured and a distance is measured to point B. With that angle and that measurement, you can compute the location of B very accurately. A measurement is made at point B, an angle, and then a distance to point C is measured. With that information, you can calculate the location of C. So this process is continued through this lot, and then eventually closing back on A. Now those are measurements, and they're designed to locate very accurately that feature. Now let's go back and review that polling question. Looking at the answers that I'm receiving on the poll, it appears that about 35% of the audience is not considering temperature measurements as measurement data, when in fact temperature measurements are measurement data. And atmospheric conditions affect measurements in the field. So temperature is collected as a way to improve the quality of the final results. So, for instance, it affects tape measurements. So temperature is a measurement. Bearings and distances are measurements. Field observations to locate or map features are measurements. Coordinate pairs were selected by about 36% of the audience. A coordinate pair is represents measurements. In other words, coordinates were computed or derived from measurements. So a coordinate pair really represents the results of some measurements. Now, if I had 2 sets of coordinate pairs, I could compute an angle or bearing and distance between those, and that would be measurement data. But an actual set of coordinates actually represent measurements. So what I'd like to do is take just a moment here and review what we've talked about, and then Christine can assist me with some of your questions. So first of all, what is Survey Analyst? Well, Survey Analyst, as we talked about, is an extension to ArcGIS, and it's designed to manage survey in our GIS system. The general concept is that if I have measurements in my database and I perform survey computations in my database and very accurately locate features, I can then link my GIS layer to the survey data and improve the quality. And then once again, what is measurement data? Measurement data are the data that we collect to locate a point on, above, or below the surface of the Earth. So I'd like to turn it over to Christine Leslie for a moment to answer some of your questions. Christine?
Thanks, Mike. We have some questions here. I'm going to read a question from Bill in Montana. Does Survey Analyst work with the current version of ArcGIS? No, Survey Analyst will not work with the current version of ArcGIS or earlier, it will work with ArcGIS 8.3 and subsequent versions of ArcGIS 8.3. Question from Dave in Clearwater. What format of survey data is compatible with ArcGIS Survey Analyst? All your standard survey vendors such as Leica, Trimble, Topcon, they will be supported. However, if there is a format that is not supported, you do have the ability to customize the importer to import that particular format. There is another question here. Can you COGO in survey data? And if so, what is COGO? I'll let Mike deal with this.
Yes, let me take that question, Christine. In fact, you can COGO in survey data into Survey Analyst, and I'm going to show you an example of that here in a few moments. But basically, what is COGO, first of all? Well, COGO stands for coordinate geometry, and I know most of you know this, but coordinate geometry are software or procedures that are used to enter measurements such as bearings, distances or lengths, and angles to resolve or define locations of points on, above, or below the surface of the Earth. So you can use COGO to enter survey measurements, and we'll actually do a demonstration of that here in a few moments. One point I would like to make is the COGO that you're entering now will go into that measurement database, and we'll see that in a few moments. Christine?
Thanks, Mike. Some more questions we have here from Sue in Atlanta. Can I type in surveyed property descriptions, like a parcel description, into Survey Analyst? As it stands, there is no standard user interface for you to do this. However, you do have the ability to create custom attributes to facilitate property descriptions. And I'll pass it back to you, Mike.
Thank you, Christine. I'd like to add one more comment to the question about typing in property descriptions, such as parcel descriptions, into Survey Analyst. When we're editing GIS features within ArcGIS, Survey Analyst maintains the data in a surveys database or a measurement database, and we're actually editing the GIS layer. So you can use your normal tools to enter values for the parcels through the editor. But Survey Analyst will have tools where you can also transfer attributes. And in fact, all the data collectors collect attributes when they make measurements. And so that data will be available. What I'd like to do is get into a little more detail about Survey Analysts and a better definition of Survey Analysts. And the way we define Survey Analysts is that it's a framework. And Survey Analysts is a framework that provides a lot of new tools. And for instance, it provides new tools for integrating and managing survey data and GIS data in a unified environment, in the same environment. And that environment is the geodatabase. What you see on the screen now is a representation of a geodatabase. This gray canister is sort of a standard representation of a database. Now, that database can be in one of the standard relational database management systems, such as Informix, Oracle, SQL Server, DB2, or Microsoft Access. In that database, we store data, much like you've seen on a previous slide. We store data as layers, and that's how we interact or operate on that data. So we'll have a layer or multiple layers of vectors. Maybe one layer represents our building footprints, and another the street center lines. So those are vector layers. In the geodatabase, we also store networks and terrain and images and CAD data. So you see the types of data that are stored in a geodatabase. And that data are stored much like we operate on it in a GIS, as layers. Those layers and those features in those layers have what are called rules and behaviors associated with those. For example, some of the rules that are associated with survey type data is maybe I'm going to conduct a survey and I have a starting point. Or there might be a rule that says this starting point has to have a certain accuracy in my survey. Another simple rule might be just the number of degrees in a circle, 360. Some of the behavior associated with surveys, for instance, if I'm conducting a survey and I measure a deflection angle to the left or to the right of my alignment, some of the behavior is that deflection angle must be a left or a right deflection. Some of the other behavior might be that when I add a new survey point, that survey point has a name as well as other attributes that are associated with it. And that's behavior. When I create a point, certain things happen automatically. Because of this, because of these enhancements, we can now model and manage survey data and measurements in our geodatabase. The way survey data are managed are by what's called a survey data set. What you see on the screen one more time now is this gray canister that represents a database. The database in this case is called Arizona. Within that database we have a survey data set called Arizona. You'll also notice feature data sets. For instance, Maricopa County parcels. That's a feature data set. You'll also notice raster data or images. So these are all contained within this data set. The way the survey data are organized within a data set is by projects. So we have a project folder called Maricopa County. Maricopa County is a project folder where we will store different data sets as projects. So we see a project called Carmel Bay and a project called Carmel Subdivision Plan. So those are survey projects. The data from those projects can come from multiple sources. It was mentioned earlier that it can come from different instrumentation. So I can have a survey instrument, for instance a total station instrument, out in the field conducting measurements. That data can be loaded into the geodatabase, in this particular case, into the Carmel Bay folder. And then I can perform survey operations and computations on that data. Other data, such as from this subdivision plan, can be entered into that database using coordinate geometry procedures, where you type in the angles and the bearings and the distances that define those features. So let's review. First of all, a geodatabase. A geodatabase is a database for spatial data. It's an implementation in ArcGIS that allows us to manage spatial data. In that implementation, we now have survey data. We manage it as a survey data set. Within that survey data set, we have projects. And projects are pretty much the way we work out in the field. You go out and conduct a series of measurements on a project, you load the data in. So within one survey data set, you can have many, many projects that define the entire scope of work. What I'd like to do now is turn it over to Christine Leslie to answer some more of your questions.
Thanks, Mike. We have a question here from Pete in New York. Will least squares adjustments be included in Survey Analyst since it is not a part of ArcMap's advanced editing tools? Yes, least squares adjustment computation will be supported by Survey Analyst, and we'll do more on this topic in a later, more advanced seminar in February. Here's a question from Kenneth in Lufkin. Does Survey Analyst work with a personal geodatabase? Yes, Survey Analyst does work with a personal geodatabase as well as with enterprise geodatabases such as Informix, Oracle, etc. A question from Dan. Will Survey Analyst be an additional cost extension or is it bundled with ArcGIS 8.3? Survey Analyst will be an additional cost extension. Here is another question from Suhail in Haifa. Does Survey Analyst handle 3D data? Yes, Survey Analyst does handle 3D data. X, Y, and Z coordinates are facilitated. And a final question. Does Survey Analyst work with GPS collected data? Yes, GPS data collected in an ASCII format in form of coordinates you can import into Survey Analyst. However, the computation facilities of a GPS software is not supported by Survey Analyst at this stage and will be supported in later versions. I'm going to take you back to Mike.
Thank you, Christine. So as we continue our discussion or definition of Survey Analysts in more detail, as we mentioned, Survey Analyst is a framework. And it's a framework that provides new tools. And some of these new tools now allow us to add new GIS features and also to improve the accuracy of existing GIS data. So what does that mean? Well, what you see on the screen now is you see a feature, a building, for instance, that's been added by digitizing off the screen from survey points. So those yellow dots represent survey points that came in from a data collector or are entered in using COGO. Those points have been computed, coordinates have been identified for those points, and now we can just digitize the GIS feature right on the screen. Another thing we can do is we can take an existing GIS feature, such as this building displayed on the screen, and we can link it to existing survey points or new survey points. So on the screen you see the Survey Editor toolbar. One of the tools is a link tool. So by using the link tool, you'll actually go on the screen, select a building corner or other feature corner, and link it to the survey point. And once again, that survey point came from the result of computations of measurements to resolve that point. So another thing we can do is actually move that building. So now you're looking at a building that has been actually snapped to survey points. So here you see where the instrument was set up. The measurements were conducted to these buildings. This particular building was linked to the survey points that define it, and then it was snapped or moved in coordinate space to the new location. The building on the lower left-hand corner of your screen represents a building that we're in the process of editing. The building is selected and highlighted so you can see that. But what has happened is we've gone into that building, identified the survey points that represent the two corners of that building, and have established a link. So the next step in the process is to select that building and move it to those survey locations, updating the geometry and improving the accuracy. So as we continue to define this framework of Survey Analyst, another value of Survey Analyst is that we can actually evaluate the accuracy of existing GIS data. Now what you're looking at on the screen is a map that shows buildings, survey points, and actual measurements that were conducted from surveys. You'll notice that there's an ellipse, a red ellipse around those survey points. That ellipse represents the error around that survey point. So that's an error ellipse. In this particular case, that error ellipse is magnified 10 times for visualization. If that error ellipse wasn't magnified, you wouldn't be able to see it at this scale because it's very, very accurate. Now, if I've computed that survey and I know the accuracy of that survey point, I know the error ellipse around that point, if I select a GIS feature, such as the corner of that building, and I snap it or move it to the survey point, I now have the error ellipse or the accuracy information about that feature vertex. It's the same as the survey point. So in review, Survey Analyst allows us to add features based on survey points. Once the data are loaded into ArcGIS Survey Analyst, survey computations are performed to resolve coordinate locations of the survey points, and then I can digitize features right from the survey points. And I'll demonstrate this in a few moments. We can also link features to survey points. So I can link a building or another feature to the survey location, and then finally I can update it or move it in coordinate space to the survey points. And then lastly, if I know the accuracy of a survey point and I've moved a building to that point, I now know the accuracy of that building. I'd like to turn it over at this time to Christine Leslie to answer some of your questions.
Thanks, Mike. We have a question from Greg in Hermosa Beach. Does Survey Analyst reduce vertical angle and slope distance to a horizontal distance? Yes, Survey Analyst has all the necessary computations needed to compute raw data imported from the field. A question from Peg. Does Survey Analyst work with ArcView 8.3 or is ArcEditor or ArcInfo required? Survey Analyst will work with ArcView 8.3 and all the functionality that you have in ArcEditor and ArcInfo will also be available in ArcView 8.3. A question from John in Albany. Can you add and work with previously adjusted survey data in Survey Analyst? Yes, you can work with previously adjusted survey data in this product. And then a question from Tom. Do the survey measurement management modules require the existence of the Survey Analyst extension? Yes, you will need the Survey Analyst extension to get access to survey data that has been imported into Survey Analyst and any other measurements that you have stored in the geodatabase. And now I'm going to turn you back to Mike.
Thank you, Christine. If I could just highlight one of the questions that Christine just answered. and that is where Survey Analyst actually works. And she is correct. Survey Analyst actually works in ArcView, ArcEditor, or ArcInfo. Within ArcView, Survey Analyst works on a personal geodatabase. So within ArcView, you can use Microsoft Access to build your survey database. Within ArcEditor or ArcInfo, it can work on a multi-user implementation as well. Another thing that Survey Analyst does for us, as part of this framework and new tools, is it provides a framework for improving workflow and processing of survey data. It provides what we call measurement management, ways to manage the measurements within this GIS. And it can really impact and affect the way that we do work. It can impact the way that we get data from the field into GIS. What you're looking at now, I'll go through a sort of a generic example of this data flow, which is also the workflow, from the field to the fabric. And obviously from the field, we're talking about collecting measurements in the field to define positions. And the fabric we're talking about is maybe the GIS layer, or the parcel fabric, or the legal fabric in the GIS system. So the process is that surveyors are out in the field collecting data, doing the field work, and they're using different instrumentation by different survey instrument manufacturers, such as Leica, Trimble, Topcon, Sokia, and other field instruments. So the data are collected. Oftentimes the data are then exported or brought into a engineering or survey package to perform survey computations. In this process, survey computations are used to resolve the raw measurements into positions. Once the first computation is done, the data can then be adjusted. You end up with adjusted locations or resolved positions of survey points. Oftentimes, the next step in this process is that data are entered using COGO into a CAD system. And within the CAD system, certain drafting and design work takes place. Oftentimes, some of these packages do more than one function. But in every particular case, in every instance, this last step, the COGO or CAD system that drafts and draws and designs, exports in a format that can be imported into a GIS system. And in every particular case, they export as a shapefile or in their own native format and import into a GIS. With Survey Analyst, this process can change because Survey Analyst allows you to load the data directly from the collector into the GIS system. Load the data directly into the measurement database. So with Survey Analyst, the process looks like this. I'm going from the field work, digital data from the collectors, loading it into GIS, right into Survey Analyst. Now within Survey Analyst, I import and manage that data. So I import it and store it in projects as units of work that I'm used to working with. Within Survey Analyst, I perform the survey data processing that was a separate package before. Within Survey Analyst, I can actually resolve those measurements into locations. I can conduct a traverse, for instance, a total station computation. So I can do the standard survey computations on the raw data and create survey points. I can also, for instance, conduct least squares adjustments by adding new data and recomputing. So Survey Analyst supports that data processing. It also supports the coordinate geometry function that we talked about for entering the measurements into this database. And once again, this COGO that we're talking about here is used to enter those measurements into the measurement database. From the measurement database, you do computations and resolve features in a GIS layer. And I'll show you an example of that during the demonstration. So within Survey Analyst, I've loaded the data, I've computed the survey. Now I can link my GIS features to the survey points. I can also edit my GIS features using the survey data. So I can adjust those points, those GIS features. I can move them in coordinate space. I can also digitize right off the screen, off of survey points, and create new features. So as you see, this is a fully integrated system where you take the data from a collector into the GIS system, perform survey computations, and edit the GIS. The last thing I'd like to talk about on this slide is that it supports incremental improvement. And it supports incremental improvement in really two areas. The first area is the measurements. By supporting incremental improvement in measurements, it means I can load survey data into my GIS system using Survey Analyst as the data becomes available. So I can have project folders. As projects are completed, I can add the data. It also means that if a survey is resurveyed and new coordinates or new coordinates for a particular survey point are available, I can go in and improve the quality of that particular survey point within my measurement database. It also supports incremental improvement in GIS features. And what that means is the example we were looking at a few moments ago, where I was editing one building. I selected a building, linked it to survey points, and moved it in coordinate space. So as more data becomes available, I can work on more features within that data layer. So it supports the incremental improvement in the features as well. The impact of this technology is pretty profound. And the impact is that in our GIS systems, we have vector data and we have raster data. And this is data that we've operated on for many years in our GIS system. With the advent of Survey Analysts and storing survey data as projects in the geodatabase, performing survey computations, and having the ability to display survey data in the same map space and use it to edit my GIS layers, we now have a new layer in the GIS system. It's called survey data. Survey data is stored as projects. So you see an example here of a school survey, a topo survey that locates features at a school, or a building survey that locates building footprints, and so forth. So in review, first of all, this data flow and workflow that we talked about, the field to fabric, and that's from the field where the measurements are made to the final fabric, which is the GIS layer, or the legal fabric for a parcel layer or cadastral system. And we know the flow, typical flow, is from the field collecting data into a survey package to resolve coordinates, into a CAD system for drawing, and then export to a survey system, or to a GIS system. Well, with Survey Analyst, you can go right from the field, right from the measurements, into the GIS system. And the impact of this is now that we have a new data layer in our GIS. We've got raster data, vector data, and now we have survey data. So what I'd like to do now is I'd like to take a few minutes and show you a software demonstration of Survey Analyst. Now what you see on the screen is ArcGIS. ArcMap is running. And I've loaded the extension Survey Analyst. So Survey Analyst is an extension. As it was mentioned, it works in ArcView, ArcEditor, and ArcInfo. Survey Analyst is loaded so I can edit my GIS features with survey data. What you're looking at on the screen now are survey points that are contained within Survey Data Set 1. So those red circles represent control points that I know the location of. I'm going to turn on some of my GIS layers, such as the buildings, the roads, and the parcels. Now this is data that we're used to working with in my GIS system, but now what you're seeing for the very first time is a representation of the survey data, the measurements, in the same coordinate space. I'm going to zoom in on this map and go into a little more detail. On the screen now you see building footprints, and you also see two survey control points. Now if I open up the survey data set and take a look at what's contained in that survey data set, you'll notice we have the survey control points. Those are the red circles. The process would be, if I wanted to improve the quality of those building footprints, or any feature in those layers, surveyors would go out in the field and set up an instrument, and they would conduct measurements at those known locations. And now you see the measurements reflected on the screen. And what you're actually looking at is an instrument setup and measurements. Those red lines actually represent the measurements that were conducted. Within Survey Analyst, I would then compute the results of that survey. I would resolve that survey into coordinate locations. The purpose is to edit the GIS features. I will come back to COGO measurements as we get into the demonstration and show you how that's represented. I'm going to go to one of my bookmarks called edit buildings, and I want to edit 2 buildings using that survey data. You see 2 buildings represented. This green building, you see the 4 corners identified as survey points. Now those survey points were computed within Survey Analyst based on the measurements that were loaded from those instrument setups. And you can see where the survey points fall within a certain distance of the corners of that building. You'll also notice on the right-hand side the location of a building that's been surveyed but is not in my GIS layer. I'm going to perform 2 types of edits here on these buildings. So as I zoom in on this first building, take a little closer look, the first thing I'm going to do is I'm going to start editing. When I start the editor, the edit session in ArcMap, you'll notice several things become available to me. For instance, the Survey Editor toolbar now is active, and which in the survey project, in this case Survey Project 1, Survey Dataset 1 that you see displayed in my table of contents, is the survey data that I'm going to use to edit, in this particular case, my buildings layer. Another thing I need to do is I need to establish my snapping environment. So the snapping environment is going to allow me to specify when I select, for instance, a survey point that you see here in the bottom, I want to be able to link it to, in this case, a building corner or a building vertex. So now that I've started the edit session, I've got my building displayed, I've selected and specified the linking snapping tolerances. I'm going to use the link tool on the survey editor bar to go link a survey point to the building corner. I'm going to do that for all 4 corners of this building. And in this particular case, it doesn't really matter the order. In other words, I can link from the building corner to the survey point or from the survey point to the building corner. This link information, when I save this session, would be stored with the building corners or the GIS feature. So now that I have that links established for that building, I want to update the geometry. I want to move it in coordinate space. Before I move it, if you'll notice, the links are represented by the red diamonds. Those red diamonds, that's a symbol that I've set that lets me know graphically that those 2 points have been linked. I'm going to use a tool with Survey Analyst to update the feature geometry. In this particular case, I want to set the feature vertex to the location of the survey point. I actually want to move that building to the survey points. I'm going to use a Helmert transformation because this will maintain and preserve the properties of the building, such as the 90-degree angles of the building corners. Once I perform this transformation, you'll notice the building has actually been moved in coordinate space. The building moved to the surveyed point. Also, you'll notice the symbol changed. The symbol now is a yellow star. So that symbology for linking and snapping is entirely up to the user. I specified this so I can see the difference. If I go in now and select that survey point, by selecting a survey point, the Survey Explorer comes up, and the Survey Explorer is the tool that I use within Survey Analyst to interact with the survey data. In this particular case, I'm going to highlight the survey point. So now you see it highlighted on the screen as the yellow dot. I selected the survey point. I'm going to go to the details of that survey point. And you can see the details of the survey point. You can see the easting and the northing, or the coordinates of that survey point. I can also go look at the quality of that survey point. The quality of that survey point gives me an indication of the accuracy. In this particular case, the standard deviation and position of that survey point is 0.037 meters. I'm going to close the Survey Explorer for a moment and examine the properties of those survey points. One of the things that you can do is you can turn on the air ellipse and display the accuracy of that point. In this case, I'm going to magnify the air ellipse information by 10. And the reason I'm doing that is so you can actually see that. At this scale, you can't see it because the survey point is very accurate, even if I magnify it 10 times. Now you see the air ellipse represented on the screen. If I were to zoom out, look at another corner of that building, you'll see the air ellipse of that corner represented. If I select that survey point, I can go into the Survey Explorer, go to the details of that point, and see the air information about that point. The standard deviation in position for that point is 0.004 meters. So you can see that the air ellipse information is different on the survey points because of the way the data computes. Another thing I want to do now is I want to edit two buildings at the same time. In this particular case, I'm going to select two buildings, and I'm going to have Survey Analyst identify the links for me. When Survey Analyst identifies the links for me in a batch process, a window comes up that allows me to specify a linking tolerance. This tolerance is determined by me, and it requires some knowledge about the accuracy of my data. So I know, relatively speaking, that the survey points, or more accurately, the building or feature locations, fall within about 3 meters of the survey point. Once I identify that tolerance, I'll have Survey Analysts identify the links for me. Now you'll notice what happened. In this particular case, links were established for 2 corners of this building in the upper right, and links were established for 2 corners in this building on the left. However, there's a situation in the middle where one survey point is within the linking tolerance of 2 building corners. In this particular case, a link conflict window comes up where I can resolve that error. Once I establish that link, I can do that interactively within the conflict window or on the screen. I'm going to solve that situation. It tells me there's one other possibility for that survey point, and that's the other corner of the building. I know that's not the case, so I'm going to resolve that link as well. So now that I've got the links established for that building, both of those buildings, I'm going to update the geometry for those 2 buildings as well. So now you'll see both of those buildings have been updated and their geometry has been improved. Another type of edit I can perform with Survey Analyst is I can actually digitize a new feature, a new building, from survey points. So I'm going to go back to that first building, and here you see the points that identify an actual building footprint that's not in my GIS layer. By actually digitizing those known points, I can add that GIS feature. So now you see I've just added another building to my building layer. So what we've done so far is we've selected one building, manually identified the links, and moved it in coordinate space. We selected 2 buildings and had Survey Analysts use a batch process to identify links for me. And when there was a possible error, the conflict window allowed me to resolve that error. And in this particular case, we just added a new building, totally from survey. The last thing I want to demonstrate is some of the COGO functionality that's within Survey Analyst. And once again, we will conduct more of this next month when we do the seminar on the 27th of February. What I'm going to do then is COGO in a building. Now you'll notice the sketch on the screen, and there's a new building that's not in my GIS layer. That building is green on the map here. One of the standard procedures to identify a feature is called station and offset. The process requires a survey point, in this case BP 1500, and we're going to survey down this line to BP 1501. The 4 corners, or 3 of those corners of the building, have been identified with what's called a station or distance and an offset. This first corner is 46 meters, 0.432 station, and the offset is 37.717 meters. So we go down that distance and over the offset to that building corner. From that point, we go an additional 9 meters with an offset of 18 meters to identify that point. And then finally, the third building is identified by an additional stationing of 14 meters and an offset of 26. That will help me identify those 3 building corners. Then lastly, this fourth building corner, I have distances down to that corner from 2 known points that we've just completed. And I'll use a distance-distance intersection to identify those. So in the process, I don't need the survey instrumentation and measurements displayed, and I don't need the new survey points displayed, but I do need COGO measurements. And as we perform COGO to create this building footprint, that data will be stored in this measurement database. The coordinate geometry or COGO tools that are available with Survey Analyst are in this toolbar. Unfortunately, we only have time to look at a few of those. For instance, the station and offset. The station and offset tools allow me to perform a station and offset to identify that building location. The first thing that happens is it's looking for the from point. I digitize the from point as BP 1500 off the screen. It's now looking for the to point. I digitize the to point. Now you'll notice I've got this line established that we're going to use to identify that building. I'll move the menu back on the screen and identify, in this case, the type of stationing. There are 3 choices. We want to use variable distances as the type of stationing. Once I select that, it's looking for the first distance down that line. The first distance was 46.432 meters. The offset at that stationing is 37.717 meters. That will establish the first point or the first corner of that building. Now it's looking for the next stationing, which is an additional 9.012 meters down that line, and an offset of 18.732 meters. So that establishes the second point. If I move this Explorer down, you'll see that my building is beginning to take shape. I now have 2 corners identified. So let's continue with this building. The next stationing is 14.9446 meters with an offset of 26.047 meters. And this will identify the third point in that building. What I want to do now is I want to use another method called direction or distance-distance intersection, as we mentioned, to find that fourth building corner out in this general area. It's looking for the first point. The first point was the first building corner we located. Now it's looking for a distance, and the distance is 16.64 meters. The second point is the third point that we identified, and the distance from that point is 21.015 meters. So now we've given the 2 distances from those points to that building corner, and it's looking for the type of solution, left or right. If I move the cursor on the screen, from this point, the first survey point, there are 2 choices. There's a left solution or a right solution. In our particular case, we see the right solution as the obvious choice. I'm going to go back to the Survey Explorer and select the right solution. Once I have done that, you'll notice the other surveyed point is now available. So we've just identified the 4 corners of that building. If I go on to ArcMap and finish the sketch, you will now see that building has been added. And you see the locations of the corners of that building. If I turn off coordinate geometry, you'll actually see the building location. So this concludes the brief demonstration of this technology. And as I mentioned, there'll be more demonstration of actually getting the survey data into ArcGIS with our presentation on the 27th of February. So as we review, Survey Analyst provides tools for integrating measurement data or survey data in GIS. It provides tools to improve the accuracy of existing GIS data layers. And it provides tools to evaluate the accuracy of existing GIS data. Some of the key points are that measurements and survey points are stored independent of GIS features. So you need survey analysts to actually work with the measurements and work on the survey. Links to survey points are stored with the geometry of the feature. That way, if the surveys are recomputed, it's up to the end user to go in and identify those points and adjust those. It's a user operation. It's a workflow. Links can be used to update the feature geometry, as I mentioned. And survey layers represent measurements and points on the map. For the first time now, we're seeing the actual measurements drawn in the same coordinate space with my GIS data. I'd like to turn it over now to Christine to answer a few more of your questions.
Thanks, Mike. Here I have a question from John in Albany. How do I track which features have been adjusted by my survey data and which have not, so that I can manage the incremental improvement of my geodatabase? The features that your GIS features that have been adjusted by survey points will have links between the feature vertices and the survey points. The features that have not been adjusted by survey points will have no visible links between the vertices and the points. A question from Michael. Can survey analysts draw new features automatically from collected data? For example, if I shoot in 4 building corners and code them similarly, will survey analysts draw the building? Yes, survey analyst can handle operation codes. If in your survey raw data there is coding, survey analyst will automatically draw out the feature for you. Furthermore, you can snap to survey points and quickly add in GIS features as you go along. Now here's a question from Barbara. Does survey analyst COGO input support azimuths, 0 degrees at south for Hawaii, for example? That's a question about formats. Survey analyst will support all input formats. So quadrant bearings, azimuth, all sorts of input formats will be supported by survey analyst. Another question from Jack. Does survey analyst support local coordinate systems to minimize ground-to-grid and meridian convergence corrections? Yes, survey analyst does support local coordinate systems, and we do have the appropriate ground-to-grid and meridian convergence corrections available through the survey analyst import wizard. I'm now going to take you back to Mike. That's all we have time for questions for now.
Thank you, Christine, and thank you very much for your questions. What I'd like to do now as we close this seminar is let you know about additional information that will be available for survey analysts. You can see on the screen now that on February 27, we're going to conduct another live training seminar. This live training seminar will be working with survey data in ArcGIS. In this workshop, we'll show you how you load survey data from a collector into Survey Analyst and perform survey computations to resolve locations, and then use that resolved computation to edit GIS features. We'll have a virtual campus course in the fall of 2003, and this course will be advanced topics for ArcGIS Survey Analyst. With Survey Analyst, there is a product book and a tutorial that comes with the product. Once again, as we close here, my name is Mike Weir, and I'm the Survey Industry Manager at ESRI. Thank you very much for your time today. On behalf of ESRI